Hello everyone. I'm Shreya and I welcome you back in this machine learning tutorial series. Till now we have covered logistic regression, linear regressions, k nearest neighbor, k, k means clustering, random forest, decision tree, now in this video, we are moving forward with introduction to support vector machines, which is another one of the machine learning algorithm, which is fall under supervised learning category. We will see what actually is support vector machine is. Okay, so as we have saw in the random forest also that we can have it both in regression and classification. So here also like support vector machine have both algorithm, that is it is in both algorithm, regression and classification. Support vector machine is a regression and classification algorithm. When used for regression, it is called support vector regression, that is SVR. Okay, so I'm taking this one. This one is there only. Hmm. As you can see, it is called support vector regression, that is SVR. And when it is used for the classification, it is called support vector classifier, that is SVC. Logistic regressions fails when it comes to a dataset with complex features, and in those class of binary classification, SVM, that is the support vector machine, plays a major role to give more accurate results. So from these points, we can see that for the complex features like complex datasets, we can't use logistic regression and linear regressions. So for in that case, the that is SVM, that is SVM, especially the SVM classifications, actually gives more accurate results as compared to the linear and logistic regressions. So this is the one of the conditions where we can use uh, you can say the support vector machine, and this is what this says the different what it is called as when it is used for regression and classification. So moving forward, we will see that what are the different terminology that is there in the support vector machine. So a sharp line separates the classes, that is suppose we have this x and y axis. So this actually helps like suppose this is the class that we have. This is the like one of the clusters that we have, and these are the one of the cluster that we have. So a sharp line, that is suppose this is a sharp line. So the sharp line separates the sharp separating line is also called as hyperplane and decision boundary. So this is called as hyperplane and decision boundary. Okay, so this is called hyperplane because it is separating the different classes. Okay, and we calculate the distance of the nearest points of both the classes from the hyperplane. So we calculate, suppose this is the nearest to this hyperplane, so we calculate the distance between them, and suppose this is nearest to this hyperplane, so we will calculate the distance as well. So it is saying that we calculate the distance of the nearest points of both the classes from the hyperplane. The nearest points are encircled with red and are called support vector or extreme points. So this is these points are encircled with red, and these points are basically known as, we can say, support vector points, or we can say support vectors or extreme points. These two points are called as, that is the nearest points are called as the support vector or extreme points. Now suppose their distance are d1 and d2 respectively. So we find a total distance d is equal to d1 plus d2, that is suppose this is d1 and suppose this is d2, so which is called as the width of the decision boundary. So this is called the width of the decision boundary, that is decision boundary is this only. So decision boundary is this, as we have already saw in the first line, that is it is called hyperplane and decision boundary. So this summation, that is d1 plus d2, is called the we can say the decision boundary. And now we try to minimize this distance to find the best fit line as hyperplane such that the width of the decision boundary is minimum. So according to that, we try to find out the best hyperplane so that we can have like the minimum, the best fit line as well. So now we will. This is the one of the pic that I have taken from the internet, and we will see this like this type of a structure when we will implement. So and you can see this is the maximum hyperplane that we have, and this is the positive hyperplane. As you can see, uh, we are getting minimum distance from this nearest point. This is the support vector, as we already saw, and this is the negative hyperplane. As you can see, this is below this. So this is, and this is very much near to this one. So this is exactly what support vector motion algorithm looks like at its final stage. So that's all in this video. Hope you liked it and enjoyed it. We will see the different applications of the support vector machines, and we will also implement support vector machine on the Jupyter notebook as well. So that's all in this video. Hope you liked it and enjoyed it. Stay blessed and try to implement this algorithm by your own, from by getting some data from the internet and by getting some of the like code from the internet. And you can take the help of internet as well in writing the code, because as I started as a starting point, it will be not very much clear for you to like get it. So I will like suggest you to like go through these terminology and algorithm by your own also, at your end also, so that it will be very much easier and it will get in your mind very clearly. So that's all in this video. Hope you liked it and enjoyed it. Stay blessed.